Hello everyone, welcome once again to another Power BI related tutorial at our channel Color Stack by Slidescope. In this part, we are analyzing the cars mileage dataset that we can get from UCI website. I will provide link and description of the dataset in video description. In this dataset, our target variable is MPG, which is miles per gallon of car. The cars that we have here is from 1960 to 1990. And for these different type of cars, we will be seeing effect of horsepower on miles per gallon, effect of miles per gallon, effect of cylinders, number of cylinders in the car on MPG, average MPG by region, displacement and MPG, average weight of car and relationship between MPG, and if we increase horsepower, will weight increase or vice versa. So we'll be seeing effect of different numerical and categorical variables on our target variable in this dataset. And here we also have these filters. So you will see all of this and learn it in this chapter. So the dataset that we will use in this project is Auto MPG dataset from UCI Machine Learning Repository. In this dataset, you can see we have some key features. So this particular data set contains information about cars and is commonly used for regression tasks, particularly for predicting the miles per gallon, that is MPG, of cars based on other features. So MPG, miles per gallon, this is the target variable which we will see how we will see the effect of other variables on this particular variable. Then we have cylinders, number of cylinders in the engine, displacement, horsepower, we have weight, acceleration, model year, origin, country of origin 1 is equal to USA, 2 equal to Europe, and 3 is equal to Japan. So here the country of origin is a categorical value that has been converted into a numerical data. But if you are analyzing it in Power BI or Tableau, so you can convert it back into the categorical data so that you can visualize it. We will see how to do that. We have car name. This is a string identifier for the car model. The data set contains 398 entries. There are missing values in horsepower column, which are often represented at question mark or NA. So in horsepower column, you will have some missing values. So obviously, if you have missing values, then you can apply data cleaning. For example, here you can see a missing value is there. Here a missing value is there, and it is widely used for exploring relationship between automobile characteristic and fuel efficiency. The dataset can be downloaded from here. This is the official website uci.edu and you can download the file. If you want, I will also provide the link for the Excel file that we have here, because in the file you will get 3-4 different data files. So I will provide the Excel file also, and then you can start analyzing it. So to start analyzing the CSV file, we will first open Power BI and simply click on Get Data and connect text CSV. From here, we will connect Auto MPG, and now we will have our file. Because in horsepower we have some missing values, and origin is also something that we need to change. So first we will transform the data. Now there are plenty of ways of cleaning it. First we will convert it to a table by pressing Ctrl T in Excel. Then in horsepower we will get rid of the blank values. This is one way. I am using a simplest way. When I will select, I can see the average is 104.4. So as all other values are integer, so I will just write the average as 105 or 104, whatever you prefer. Here in your data set, you will simply right click here and select replace values. Values to find is null, and we will replace with 104 or 105, whatever average you want to keep. And now you can see all the values are created. Obviously we will have two 104 values, so this is one way. Either you can drop that those rows where this value is missing, or you can replace them with a mean value. Okay, so like here you can see 104 is there. Next up, we also have origin. So origin is either given as 1, 3 or 2. So we can replace values here also. Value to find 1, and 1 is USA, 2 is Europe, 3 is Japan. So we'll simply use 1, replace it with USA. First of all, it will not let us replace because this column is a numerical column. So if you want, what you can do here, you can make a copy of this column. So we will copy this column. So let's simply duplicate the column, and let's say this is, we will simply name it as origin name country. So this is origin country. First we will change its data type. So just go, first of all click here and change its data type. So change its data type to a text value first. Now after changing its text value, changing it to text value, replace values. Value to find 1, let's say USA. Similarly, replace value. Value to find 2, Europe. And obviously it should have been origin continent or something, but it's okay. And then replace value. Value to find 3, Japan. Click OK. Now we have a categorical column, and we have cleaned the data set a little bit, and we can simply close and apply, and it will simply load the data set. If before starting the project, please save your file, and we will simply call it Auto MPG analysis. The purpose of this type of data analysis or exploratory data analysis is to see the effect of different inputs on our output. The output is miles per gallon, kind of the mileage of the car, and we will see how different features here are affecting our target variable. Now we will simply insert a text here and let users know cars mileage analysis, and you will simply arrange it to center. And anytime when you are starting to analyze things, you can choose a color palette from here. So let's say we are selecting this palette, a dark background here. In the background you can always go and customize current theme. Here you have page option, and in your dark background you can apply some transparency in order to make it lighter. Now this is the text box, right? In text box we can go to effects, and its background color is also something that we can choose accordingly. So whatever color you want to choose, you can select that. So let's select this color here, and we can also enable a shadow here. This is obviously the cosmetics part that you can do later, and that's how you can simply create your heading. Now in cars mileage analysis, the variable or the target that we are trying to analyze here is miles per gallon. So first of all we will see the distribution of miles per gallon, like what is the minimum value, what is the maximum value, and in each range how many different type of cars do we have. One thing that you will see here in your data set, if you don't see a column that represents ID of each row, so you can always go back to the transform tab, and you can start transforming the data. And in transforming we can go to add column, and we can add a index column from 1. Go to home, close and apply. This index column is a unique value for each row in the data set now. So when you will go here, you will see this, right? If you will arrange the data in ascending order of index, so now it will be arranged like this. Now we will take a stacked column chart here to see the distribution of our mileage. So here we will simply drag on x-axis, we will drag mileage, and on y-axis we will drag how many distinct values do we have in each range. So here we will add index. Now you will see, let's expand this, that the mileage starts from around, lowest mileage starts from around 9 and highest mileage starts ends at around 46, okay, in the different cars that we have. Now this data is obviously kind of a histogram plot, but in order to visualize it with more effect, we can go and create a new group. So click on these three dots, you have different options. So we can create a new group. Currently minimum value and maximum value have a bin size of 2.5. Okay, let's say we will just display the data. So these are number of bins here. Every bar here is a bin. Let's say we want to display the data in 10 bins. So now the bin size will become 3.7. So you can create a calculated column from a numerical column, and this will now become a bin. So 12, 16. So every bin size is 3.7, right? So 9, then 12.76, then 16.52, and so on. And now we will just replace it with our bin. So this is the sum of index by MPG. So this is simply nothing but distribution of MPG in the data set. Okay, you can use heading like this, and on your charts you can select a different type of background if you want, or you can simply go to effects and enable a simple shadow. Okay, you can also enable a border. So for example, we go to effect and we create a visual border. You can select a visual border color as per your selected shadow color. Shadow color is white. We will also select a visual border color that is also light color. So this is distribution of mileage. Okay. The main purpose of seeing this distribution is to check how many cars, like in which particular bin do we have the maximum number of cars. For example, sum of index, it is showing sum of index. First of all, we have to change it to count of index. Now this is the data. So you can see cars with mileage of around 9 are 13, mileage of around 70, 12.76, 78, 16.5, 73, and so on. So every bin here is representing number of cars in that particular mileage range. If you want, you can click on it, go and enable the data labels also. So you will be able to see those numbers here as well. Okay. For some reason, when it's a small, this data, we can only see some labels, but you can adjust the settings and you can display the data. Level intensity is also that you can increase or decrease so that you will be able to see. You can also enable overflow text, optimize label, so then you will be able to see most of these values. So you can see cars having mileage of around 42.84 are 6, and most cars are 78 and 73 are in the mileage range of 12 to 16. Now we have understood how data is distributed, how our target variable is distributed. And now we can see effect of different variables on this mileage. Whenever these variables are given, they are given as numerical variables, or it can be a categorical variable. For example, we have different type of car names here. You know, there are a lot of them. So obviously, if you want, you can see all of them. For that, you can create a clustered bar chart here. And first of all, we will copy the same styling here. And in clustered bar, we have y-axis and x-axis. So on y-axis, we are going to drag the car name, and on x-axis we will drag the MPG value here. Okay. Obviously, this is showing sum of MPG value because we may have different samples of this car. So we will use average here. So you can see on an average, Mazda GLC 47, Honda Civic 15, 100 GL 45, and so on. So you can see their average mileage per gallon for these cars, and these are actually all the values. If you want to see in a specific range, you can also show this value as a filter. So for example, let's select this group. So you will be able to see in this group different type of values, this group different type of values. And if you want to show this filter properly, so what we can do here, we can use a slicer. When we are dealing with a numerical value, the slicer may be given as a slider also. So we will simply drag it here, and first of all, to this slicer we have to add a field. So we will use our MPG as a field. So here you have minimum and maximum value, and here we will also go to slicer header, try to increase its size. Okay, or we will disable the slicer header and generate a simple title MPG and reduce its value to some extent that MPG is available. Now we'll make it bold. So this is MPG here, and we will just enable some kind of transparency in its effect in background. So when you will enable some transparency, it will blend with background color also. So here we have minimum and maximum value. In such cases, in your slicer, you will see different type of settings. It will be between, it will be a tile, it will be a drop down. So for example, it's a drop down. Let's say we want 19, we want to see 19, right? Whatever you want to show, you can show it here. So slicer settings, we will select between, and let's say we want to see cars that have mileage between 30 to 40. Then you will see 30 to 46 and hit enter, and you will see the different values 30 to 47, obviously the last value that we have. So this way you can see effect of different type of mileage here. So we will use 9 to 47, which is the highest value. So this is our car's mileage. Obviously now we can reduce its width also. The only width that is needed we have already done, and we will be able to see the different mileage effects on different type of range also. Next, we also have the origin country or the origin region. That will be a proper name here. So we will simply rename it as origin region, or let's simply call it region of origin. And here, this is also a categorical value. So in this case, we are going to use our donut chart. We will again copy the same formatting style here, and in legend we are going to bring region here. So it will automatically select three different colors for three different regions, and we want to see is the average MPG different for cars of different region, right? So we will add values here, and this will give us sum of MPG. So we will simply use average. So you can see on an average, all the cars that we have, the average of MPG is 30.45. This is 27.89 and 20.08. So if you are in India or any country where it is considered as kilometer per liter, mostly we consider mileage in kilometers per liter. Let's say on an average we are seeing 30 here. So which is close to 12.7. Highest is 47, which is close to 19.98. Okay. So this is miles per US gallon. So that way we can understand, and this is the average value that we are seeing here. And 30.45, 27.89 and 20.8. Now in this kind of chart, let me see why is not copied. Yeah, in this kind of chart we can go to data labels, and let's say we only want to show category value, okay, or we want to show category and data value. So that will be better because this is category and data value. In value, number of decimal places we can show 1 or 2 maximum. You can also increase the size here, right? So in values, let's say we want to show 10 will be okay. And this is the unit. And rotation, we can rotate it so that our values are visible properly. So this is the use of different type of formatting settings that we have for a donut chart. And this way we can see, yes, in different regions we do have different average range. For example, in US the all cars average 20, in Japan 30, which is a big difference. So when we are when you will create a model that will predict the miles per gallon of a car, and you will provide different types of input there. So this region input will be an important feature to consider, right? Because it has the different values that we have different kind of effects. So this is distribution of miles per gallon, this is average, and this is average by region. You can also put different type of things like region. If you want to see region wise distribution of number of cars, right? So you can also add it as a legend here. So you can see Japan cars here, like here in region Japan we have 24 cars, then 9 cars of USA, and the bin size is 31. You can see in higher averages or in higher value of MPG, you can see the distribution of Japan is increasing. But in case of lower ranges, we have more cars of US region. So this is something that will be helpful. Either this way or this way, you can visualize the data. Up until now, we have seen how to see distribution of one numerical value, one continuous numerical value, how to see effect of one numerical and one categorical value. For example, average MPG and car name here. We have seen again in this case also, in this case because number of values were more than 20, 30, so number of different values, so we used a clustered column so user can scroll through. And here we have used a donut chart because we only have 3 values. Now in order to compare a numerical value with another numerical value, what you can use is scatter plot. A scatter plot is also a relational plot which shows if one particular value will increase, what will be its effect on other value. So for example, we have acceleration here. Okay, so let's see different type of values. Acceleration, or let's consider horsepower for example. So you can see minimum horsepower is 46 and maximum is 230. So you can see in horsepower 46 to 200, and so we have minimum and maximum values here. And when you have to compare a numerical value with another continuous numerical value, you can use a scatter plot. Here on x-axis you have to put that particular value which is independent. So for example, on the basis of horsepower, what is the y-axis value, which is what is the miles per gallon of all the cars that we have. And here we can select don't summarize. Here also we can select don't summarize. Now you will see a simple scatter plot here. And first let's copy the formatting. So in this scatter plot, you can see the trend is when horsepower of the car is increasing, then miles per gallon is decreasing. This is for different data points that we have. And if you will simply go to further analysis part, here you can enable the trend line and you will see a downward trend line showing us that x-axis, when there is an increment in x-axis, there is a decrement in y-axis. And that's why whenever we'll create our model, this will be very important to consider that horsepower has a negative effect on miles per gallon. Now similarly we also have acceleration, number of cylinders, etc. For example, let's see number of cylinders. Obviously it is a numerical value, but it will be more like a discrete value, right? 3, 4, 5, 6, 8. So for that we will only consider a stacked column chart. So we will simply make a copy of this, and after making the copy we will just, instead of count of index, we will simply add mpg bin on y-axis, not bins. So we will add mpg on y-axis and we will add cylinders here. Okay, it is showing sum of mpg, but we will say average mpg. Now what is this? Here you can see, and just to analyze, because we don't want to see region here. Yeah, so just to analyze this, you can see here that cars with 3 cylinders have an average mpg of 20.5, 4 cylinders have 29, 5 cylinders 27, 6 cylinders 20, 7 cylinders there is no data, and 8 cylinders 14.9. Okay, so this way you will be able to see that cars with 4 cylinders have highest average value of miles per gallon. We also have different uh, you know countries here, different regions here. So that might have been selected, and suppose you want to see for USA or Europe. So now all this data will change for Europe. For USA, you will see all this data will not change for USA. So this is something that you can see, and that's why we can also create another filter here, and that filter, in that filter, instead of mpg here, we will use the region and show it as a tile. Okay, so if you select Europe, you will see data for Europe. If you select Japan, you will select data, see data for Japan, and USA, you select. You can unselect them to see all of them at one time. You can also click on this. In your values, you can see the different font colors. You also can see background color. We can choose a different type of background color, because whenever we are selecting them, one of them becomes black, which is the default font color for this value is selected. So this way you can see, for example, in Japan 21 31 is the average for 4 cylinders, and we will simply name it as mpg by number of cylinders. And we can say the number of cylinders do have effect on our outcome, the mpg. So best outcome will be achieved in cars which have 4 cylinders. 4 cylinder cars are also you know smoother in operation than a 3 cylinder car. Like the cabin noise, etc. But we are not considering those kind of elements here. Next, we also have a column that represents model year. So this is model year 70, 71, etc. Right? And luckily we have values up to 82. So we can see the data is from old cars, that is from 60 to 90. No, not sorry. Yeah, yeah, 60 to 90. So again, by going into transform tab, so just go to transform tab, we came here and we just copied the model year here. So we just duplicated the column, and after duplicating we just save this as new model year. Now let's say we want to add another column here, and we go to add column tab. From here I will create an index column custom. I will say starting index 90 and 19 and increment is 0, because all these values are from 1990, 90, 70, etc. Although it will not make too much of difference, but just showing you different uses. And now we have index here. So this index 1 is actually year prefix, we can say, or whatever you want to call it. So let's write year prefix. Now we have year prefix as 19 and model year as 70. So for every row we will use, again go to home, and in column tab we will use merge columns. Separator is none, we are not going to use any separator, and new column will be new year, just calling it new year, not happy new year, new year. So now you can see 1970, 1960, 70. Okay, now we will go back to home, close and apply. And since year is now a date, is year obviously, so before saving you can always change its type, and in change type you can see date, date time, time, duration, etc. First of all, it will not be a text. Okay, so you can use it as a whole number, or you can also use it as a date. Okay, when you will use it as a date, let's see what happens when we use it as a date. Close and apply. So that new column will be created, and for every year it will select first date of that year. Okay, so this can also work, or you can select it as a whole number, so that will also work. Now when a date is created, we will already have in a date hierarchy, from where we will already have the year. Here quarter, month and day will not make sense, but obviously we have the date here. And whenever you have a date, you can use a line chart to see any numerical value. Okay, so the whole idea is, obviously these cars were made in different dates, right? Not just dates, or in different years, different. And we want to see, as technology evolved, right? Did that technology made any effect, or that did that technology had any effect on the MPG of cars? So for that, here on x-axis we will drag year. We could have done it very simply, just drag year which was already given and just add MPG here, but we want to learn things, that's why. And here you can see, as per the cars that we have here, in those cars in 1960, this is sum of MPG, right? 1960, this is sum of MPG. What we would like to see is average MPG. So now on the basis of different years, we can see in 1960, 62, the highest average of a car in terms of MPG was in 1980. Okay, suppose you want to see effect of different categorical values here. First of all, let's copy the styling. Categorical, by categorical value I mean in legend, what if we drag region? So you will see for different cars. Like, eh, interesting thing is the first value that we have from 1960 is from a car origin Europe, and so from that period up to 1989 we have all the values, but in USA we have values only up to 1987 from starting from 1963, and this way you can see for different countries, and Japan maybe started creating in 1970 or obviously or as per this data set, but we can see that these two variables here do have great impact on our outcome. For this type of chart you can always select an area chart also, which will show you similar type of analysis, and you can select a stacked area also. In a stacked area you will see graphs over each other. All of them are good ways to analyze effect of air. So let's select area chart just as a reference, and here I will just edit the title. Instead of average of, I will simply write average MPG by year and region. So we have seen effect of number of cylinders, we have seen effect of year, horsepower. Now similarly, we can also see effect of displacement over displacement with MPG. So let's copy this, and here in x-axis we will bring displacement value. Instead of horsepower we will simply bring displacement and say don't summarize. So as per the description of data set from different sources, engine displacement in cubic inches is given here. So from here we can see we have one outlier here, 3000. Maybe it can be an error. So but most of the values, most of other values are within 500 range, right? And we can see a downward trend here also. That means when displacement value is increasing, we do have lower MPG values. So here, let's say we go to filters on this visual, okay, from here, and we say displacement is less than, and we say 500 because that is the value that we want to see. Let's try. Let's apply the filter. Now you will have a better graph to visualize here because that's an outlier, obviously, that we can tell from all other displacement values here. Let's see here, right? All the values are between 68 to 455, then we have 3000. So this way you can choose some outliers, you can omit some outliers also. So we have seen effects of different type of variables. So acceleration, cylinder displacement, horsepower, model year, origin. Now the one that we have is weight. So now what I have done, I have just rearranged them, and in properties I have kept the height as 203 and width as 400 for all of them. So let's say we want to do this, so we will just write 400. Okay. So this way we have fast mileage analysis and we have displacement, and similarly because weight is also a numerical column, so we can also use similar kind of analysis for weight. Like obviously when weight increases, mileage will go down, and that's what we can see here. So this is sum of weight. We obviously because we are analyzing data for each car here, so we can use average weight here. So you can see pretty decent linear kind of thing, and later you can apply linear models to find out the value of intercept and coefficient of this line. So suppose if you have to find, if suppose weight is, average weight is around 4000, right? So in that case, you can select, you can find out what will be the average miles per gallon be of that car. And as per description, weight here is in pounds. So if you want to analyze it for any other region, you can convert it to kgs also, or tons, in which most of the cars are car weights are measured. So here we have seen effect of all input variables on our output variable or target variable, that is MPG. Just want to show you one thing. Suppose you want to see like if horsepower and weight are correlated. Okay. So just want to show you. So in this case, you can use them also. Okay. So for example, we remove these two values from here and we use horsepower here and weight here, right? And we say don't summarize. So here you can see when horsepower of a car is increasing, weight is also increasing. And that's why these two graphs are almost similar in trend. And so will be the effect of displacement. Here, if you want to see for different type of cars, you can choose them in legend here. But we have so many different type of cars, so we don't want to do that. And finally, if you want to decorate your chart, you can bring some image, some contextual image explaining your chart. So you can go to insert tab and from here select the image. So we have added a sample 1970s car here, just a icon. So the, this way you can add an image here, and obviously it's not needed necessarily, but just adding. So this is our car's mileage analysis, and we are seeing effect of different type of variables. If you like this analysis, if you like this tutorial, then please subscribe to our channel. That helps us, and it will also help you whenever we will upload any other video about Power BI analysis, Tableau analysis, or through Python pandas or SQL tutorial, anything when we will post. If it is useful for you, you can watch that. You will learn data analysis related stuff. Thanks for watching. Have a nice day.